Hey guys, today we're doing a tune on R34 Skyline using an R32 ECU for an example with an RB25 engine, 1000cc injectors and HPX airflow sensor. So the first thing we're going to do is go to the file and select vehicle, then scroll down to the vehicle ECU, which is a HCR32 ECU. Now click on console and we'll connect to the vehicle. It's picked it up as a feature pack ECU, so we'll just auto load that address file. Okay, select the registers that you need to look at during your tuning and then click OK. Now hit the download button to read the maps off the ECU. If this is a fresh tune, you can also upload the factory maps, which we have in our ROM pack, to the ECU. What we're going to do now is we're also going to load up a comparison image. This will allow us to see the changes that we make to the ECU while we're going through our tuning. And I'm going to click the compare button and that will show which maps are different. Okay, the first thing we're going to do is we're going to select the different injectors. So we're going to go operations resize injectors. Now normally the factory CC is 270 for the R32 ECU, but since we already have this configured for an R33 factory ECU, they run the 370cc injectors. We're changing those to 1000cc ID 1000s that we're running. I'm going to leave the cranking tables alone because I know on these injectors they require a high pulse width during cranking. Using the automatic calculation seemed to pull it too low from previous trials. So we've done that. And we need to then upload those maps to the board. Okay, so we're in sync with the board now that we've done the upload. Whenever you change any files or anything like that, you will get out of sync, so you will need to hit the upload or download button depending what you wish to do to make sure that the maps you're seeing on the screen are the same as the ones in the ECU. The next thing we need to do is adjust for the airflow meter. Now normally we'd go resize injectors, resize airflow meter. In this case the resize airflow meter, we would want to select the HPX N1. However, the airflow meter is 1570 horsepower. We're not going to use the full range of the airflow meter on this vehicle. This vehicle, we know on the dyno test that we've done previously, is about 300 kilowatts at the wheels. So what we're going to do instead is we're going to go to display and then select the VQ transfer generator. What this does, and you'll see in a moment, is it will alter the voltage quantifier map, which is used to convert voltage into load used by the ECU for its indexing into the fuel, timing and etc. maps. Okay, so what we're going to do is we're going to set this up to use 45% of the total flow capacity of the airflow meter, and we're going to click apply to that. Okay, so that's done. The next thing we're going to do is we're going to look at the K constant, which is the total load multiplier, as well as the total injection multiplier, which is just used to adjust for injection size. Now the K constant you can see is unmodified from factory, so that's still got the load for an RB25 airflow meter. Meanwhile, the total injection multiplier has been changed, and that was done during our injector resize. Now, because we've used this function generator, we have told the ECU that it's got a different VQ map, but we haven't told it the extra load capacity of the airflow meter compared to a factory one. A stock R34 airflow meter will do about 230 real world kilowatts. Meanwhile, we're setting this new airflow meter up for about 350 real world 400 kilowatts. So it's approximately double what the previous airflow meter size was. So we'll change it from 187 to about 360. And after this we'll adjust that until we get our tuning about right. Okay, so the next thing we're going to do is we're going to connect to our wideband. So basically we need to make sure the wideband is configured. We go to File, Configuration, Innovate Select, and we've got a USB serial converter on that. So click Connect and we should get a pop-up. Okay, so now we're connected to the wideband. Next thing that we need to do is start the vehicle. I'm just going to open up the console view so we can watch everything while it's cranking. We've got a DTC fault code for the TPS, so we're just going to clear that out and see if that reoccurs again. Alright, so we had a crank then and then it kind of stopped afterwards, which means the cranking table's about right. It got the engine started, but then it started dying off after that. Okay, so what we're going to start first is start cranking the engine and see how we go with that. If you're having problems cranking, the first thing to look at is the cranking reach table. The cranking reach table tells the ECU in a number of milliseconds how long to open the injectors for while the start switch is activated. We're going to gradually increase the bottom end of this table, which has been accessed until the vehicle starts. So we're at 4 milliseconds at the moment. It's just kind of kicking over but not very well, so we're going to bump that up. Try again. It's going a little bit longer, so 5 milliseconds seems to be working okay. Okay, so what we're doing now is we've just restarted the vehicle, and the trims were reset and running quite lean. It's suddenly just adding in a whole lot of short-term fuel trim, so we need to still increase the amount of fueling for the vehicle. So we're just going to bump that up a little bit, and we should be good to see how the AFRs are over the entire fuel map. Well, I'm going to open up this tracer. The tracer allows you to graph any kind of sensor input, including AFRs. So we can rev it up a bit and get an idea. So there is still quite rich up the top end. So what we're going to do is we're going to flatten the fuel map. So what we're going to do is we're going to flatten the fuel map. We've got a tune that I've done previously with a flat fuel map in it, so we'll just copy that across to show you what it looks like. There's our main map there, and the compared image shows the flat fuel map underneath. So we go to copy, and this allows me to copy a fuel map from one image into another. So we're going to copy from compare to main. Now I've done that, I need to upload the maps back into the ECU. Okay, and that's done. Now what we'll do is I'll reset the tracer. And that's running still a bit too rich but better than before. So what we're going to do now is increase the injector latency, and the tune we were working on before had it around 900. Now what we've done is we've adjusted the injector latency. That'll make our idle a little bit richer, and we can afford to pull back the total injection multiplier just a bit. Just keep in mind the trims when doing this. Trims look fine, they're around the 3-4% mark, so they're looking good. We'll reset and we'll try this one again. So we've got about 11.5. What we'll do next is we'll do some proper drive trials and some logging while we're doing that. So you can see from the trace we've done here, we're still a little bit too rich. We're running about in the low 10s up the top end. Midway looks good, the bottom end is on target as well. What we're going to look at next is the logging capability inside Nistune. To do this, we need to turn Nistune from tuner mode into stream mode. This performs a high speed streaming operation inside the software. We then open up the log player. Select the parameters you need to look at. In this example we can see the RPM airflow meter air fuel ratio as well as the injection time. Hit the record button and then we're good to log. We're going to do another test run. So the logger will record air fuel ratios. You can also hook and boost throttle position, temperature. That's the end of our log. Now we're going to stop the log and we'll use this for playback. To enter playback, we need to disconnect from console and the wideband, and the log will automatically go into playback mode. From here we can hit play and we can see the tracing on the fuel and the AFR maps while we're doing our test run.